What holds elements together into compounds? Well, the atoms of the elements are held together by chemical bonds. And chemical bonds, most broadly described, result from the attractions between charged particles that compose the atoms. So we have positive protons and negative electrons in each atom, and the attractions between those are what form the bond. There are different kinds of bonds, though. The two categories that we will look at are ionic bonds and covalent bonds. Ionic bonds are going to be between a metal element and one or more non-metal elements. These involve the transfer of electrons from one atom to another. So when a metal interacts with a non-metal, it transfers one or more of its electrons to the non-metal. The metal becomes a cation, the non-metal becomes an anion, and now they're oppositely charged, and they're very attracted to each other, like magnets. And so an ionic compound is like a bunch of magnets sticking together. In the solid phase of an ionic compound, we will observe a lattice. That's a regular three-dimensional array of alternating cations and anions. There's a definite order to how those ions are arranged. Here is an illustration of the formation of table salt, sodium chloride. Sodium metal, chlorine gas. Here we have sodium atoms and chlorine atoms. They're both neutral. The neutral sodium with 11 electrons will lose one of its electrons, giving it to chlorine. So chlorine goes from 17 electrons to 18. Now it has a negative charge. Sodium goes from 11 to 10, has a positive charge. And so these will be attracted to each other. Sodium ions will be repelled by each other. Two chlorine ions would be repelled. And so they're going to arrange themselves to maximize the attractions and minimize the repulsions. Covalent, the prefix co means shared, like a co-op or co-sleeping with your child. That means your child sleeps in your bed with you. So covalent bonds, and valent refers to the electrons. Covalent bonds involve sharing electrons. And we're going to see these between nonmetals. So when we have a nonmetal bonding with another nonmetal, nonmetals, if they're going to make an ion, are going to make a negative ion, an anion, which means they want to gain electrons. If you have two nonmetals, neither's willing to give up an electron to the other, because then it would have to be a positive ion, and they both want to be negative. So no one's willing to give one up, so they decide to share instead. Here's an illustration. Here's the positive nucleus of each atom, and here's an electron that's being shared between them. You know, we can imagine that electron being in various places, but the most stable will be if the electron is between the two nuclei. That will maximize the attraction and lower the energy. So, unlike an ionic compound where we just have an arrangement of ions, here we have discrete molecules. Each molecule is independent of the others and has its own, like oxygen and hydrogen, making water, 2 hydrogens, 1 oxygen. That's a discrete unit. We call covalently bonded compounds molecular compounds because they have molecules. Ionic compounds have ions.